Hi. How many ways can we arrange the letters in the word Mississippi? If you don't know how to do this, that's fine. I'll teach you right now because that's what I do. I like teaching. First, let's start with an easier version of the problem so we can understand what is going on behind the scenes. For example, let's start with the word fun. How many ways can we arrange the letters in the word fun? Because math is fun. Well, okay, at least for some people. So fun has 3 letters. A simple, logical, and intuitive way to do this is to visualize the number of ways that we can arrange those letters. For example, we have F, U, N. We also have F, N, U. We also have U, F, N, U, N, F. And finally, we can have N, U, F, and N, F, U. That gives us a total of 1, 2, 3, 4, 5, 6 ways that we can arrange the letters in the word fun. So that's 6 arrangements or 6 permutations. That's how the textbook defined this, permutations. Easy. But what about for longer words, like Mississippi? Do you really want to write out all the ways that we can write out the letters in the word Mississippi? Not really. That's not fun. But math is. And math is also very useful and makes our lives a lot easier. So for 3-letter words, what you would do, give me a second please while I can erase this, is you count how many letters we have total, and we have 3. So that's 3 factorial. Factorial is actually really simple. The exclamation point means that you want to calculate the factorial of whatever number it is attached to. So to calculate 3 factorial, for example, we will do 3 times 2 times 1. So 3 times 2 times 1, which is 6. Therefore, the answer is 6. We have 6 permutations of the letters in the word fun. But we knew that because we drew it out. But what happens if we have longer words, more difficult words, like Mississippi, right? On top of that, the word Mississippi has letters that repeat themselves, like the S and the I and the P. That's a bit more difficult, but we follow the same process. And the fact that these 2 letters repeat themselves, and we have a lot more letters that repeat themselves in this word, that means we have fewer permutations than we would normally expect. This is because when you have 2 of the same letters, it doesn't matter who goes first. For example, if you have S and S, it doesn't matter which S goes first. That counts as 1 permutation. But again, math comes to the rescue, right? And helps us figure out what's going on. It's easy. What do? You calculate the number of letters that you have on the top in the numerator, and then you divide that by the number of times each respective letter repeats itself in the denominator. So that's in the bottom. Then you will get the answer. So to illustrate this, for example, we have 11 letters in the word Mississippi. So that's 11 factorial on the top. In the denominator, we write 4 factorial because we have 4 times that S repeats itself. We have another 4 factorial to represent the 4 I's we have. And what else do we have repeating? We have P. P repeating twice, so that's 2 factorial. We will normally then expand this, but be careful. 11 factorial normally would be 11 times 10 times 9, etc. But it will stop at 4 because 4 factorial cancels out with this 4 factorial. Therefore, you would have 11 times 10 times 9 times 8 times 7 times 6 times 5. Divided by, you would stop right there, so 5 divided by, still 4 factorial, which is 4 times 3 times 2, which is 24, times 2 factorial, which is 2 times 1, which is 2. 11 times 10 times 9 times 8 times 7 times 6 times 5 is exactly 1,663,200. That gets divided by 24 times 2, which is 48. You would simplify that because that's what we do, and you get the answer. 1,663,200 divided by 48 is 34,650. There you go. So that's our answer. We have 34,000 ways, at least, because we have exactly 34,650 ways that we can arrange the letters in the word Mississippi. That's it. Thank you.